Configuring router on a stick. On our Genius 3 lab, we built two different networks for sales team and for marketing team using port 2 and port 3 on the firewall. We want to be using VLAN trunking to build different layer 3 network or different layer 3 segments on the same port using VLAN tags. For example, we will be building port 4 for design, IT, and HR departments. This way we can trunk all these three departments on one port and use this small VLAN tag. It's a small header that gets added to the packet, and it allows you to segregate and separate traffic going on the same port. Maybe you have a device that have a port with high capacity, maybe a 10 gig connection. In this case, you can trunk multiple networks on this port, knowing that you have enough capacity to load all this traffic on one port without causing a bottleneck in your traffic. So I designed three different networks, a /24 for each department, and choose a number for each one. And for VLANs, you can choose any number between 1 to 4096. In most cases, you are not recommended to use the VLAN number 1, which is the default VLAN, for security reasons. So I choose different number from the VLAN 1. And I want to show you how the traffic looks like without VLANs first. And then we will apply these VLANs on port 4 and see how difference does it make to a normal layer 3 packet. Let's open our sales PC one more time and try to run a ping to our marketing PC. And this way we can have a flow running from this device going into switch 1, going into port 2 in the firewall, utilizing the firewall policy that allows ping between port 2 and port 3 that we created in the previous video. And switch 2 will forward the traffic to a marketing PC. So if I do ping 10.10.200.50 and I put -t in the end, this will run a constant ping into the marketing PC. Now we can use the sniffer feature in Genius 3 to watch this traffic flowing using all these links. I want to show you how to do so. Right click on this link right here and click Start Capture. And once you select the correct interface, this will trigger Wireshark to open. And Wireshark is one of the best tools you can use to learn networking and see traffic in real life. Once Wireshark loads up, you can start seeing the traffic flows between the interfaces. We have enough packets right now to see some useful information, so we can stop our sniffing to make it stop loading, and we can see here the flow between the ping request and the ping reply. And the ping request is coming from our sales team PC and going into the marketing PC. We see here the content of the packet. This is the layer 1 stuff. You won't find a lot of useful stuff in here. And here we just see the source MAC address and the destination MAC address and the type of this packet. But there is nothing regarding VLANs in this situation. Now let's take our example for port 4 and start applying this in the firewall. So we're gonna deploy a new Ethernet switch to connect the clients from all these three different departments. And this time we're gonna be making a tweak to the switch. In the default settings for the switch, we did not have to change for the sales switch or for the marketing switch, because the default configuration is just to allow all ports to be in access mode. And access mode is just allow a single host to a single VLAN. And all the VLANs by default is VLAN 1, which is just the native VLAN or the default VLAN. And this time we're going to be designated a port to connect to the firewall. This port is going to be called a trunk port. And the trunk port allows different VLANs to go on the same channel, but still be segregated. So for this case, let's use port 1 And once we double click it, we need to change it from access to .1Q. So we designated port 0 as our trunk port. This is all we need. Once it's selected, all the VLANs will be allowed in this. But in real life, if you have a layer 2 switch, you can selectively allow VLANs 25, 33, and 47 on that port instead of leaving it more liberal like GNS3, but this is the way it works here. For the different ports, let's say we're gonna be using port 1 for our design department. And the way we do this, since these ports are gonna connect to actual computers in the end, they can be left to access. But for port 1, we wanna allow only design department. So we're gonna change this to a tag number 25. So this way, if a device sends traffic to this port and it's not tagged with VLAN 25, it's not gonna go through. Now that I added all VLAN numbers, I now have port 0 that is configured as .1Q. This is my trunk port and it will allow all these 3 different VLANs to write through to the firewall with no issue. But port 1 will only be allowed for design department, and for IT it will be port 2, and for HR it will be port 3, and you can change the remaining ports to anything you like. But the best thing is all these other ports are set to 1 by default. That means the firewall will not be able to communicate with anything that you did not define, because VLAN 1 will not be configured on the firewall at all. And now we have all the layer 2 stuff ready. Now we can start building our PCs and configuring the FortiGate side. So now we know that we need to connect port 0, the trunk port, to the firewall port 4. So we can run a link from here, from Ethernet 0 to the firewall port 4. And we're gonna be using the firewall to create 3 different VLANs as well. And this way we can use the FortiGate to route between different VLANs on 3 different layer 3 segments. Let's see how we can build 2 VLANs on the GUI and build the remaining one on the CLI to see the difference. So I want to open my GUI again, and I want to log into it using my admin and password. And if you go into network and interfaces, here we see only the 4 physical interfaces that are in the box. I don't see any VLANs in here. The way you can start configuring VLANs, you just create a new interface. When you create a new interface, automatically it sets the type to VLAN. There are different kinds like loopback interface or a Wi-Fi ID or a virtual switch, but VLAN is what we need to use here. Let's start by doing our design department. And for design department, we will be using our 192.168.0.0/24, and this will be stamped with VLAN tag 25. So let's see how this works on the FortiGate on the GUI. We're gonna put our network in here under port 4, because all the VLANs will be trunked under port 4. And the VLAN tag for this will be 25. And once we put the network here, we can choose the first IP as the interface or the router IP on the FortiGate. And now we can allow ping on this interface, so all the clients behind design network can ping 192.168.0.1. And we also gonna allow the DHCP server. And it already selected all the valid IPs in this range for me, so I don't have to do anything else. So now I can just save. And now if you see, now we have a plus button next to port 4. And we can see all the trunks that are running in this port are listed in here in a nested format. So now we created our first VLAN. Let's go back to GNS3 and do our IT department, and this we will be using VLAN tag 33. So create a new VLAN interface. port 4, VLAN tag 33, and we're going to be choosing .1 for our address, and we're going to be enabling our Bing and our DHCP server. Click OK. Now I have two different VLANs for each port, and I just need to create the last VLAN, but let's see how we create this VLAN using the CLI. So double click on your FortiGate to start a console session to your firewall, and I want you to write the command config system interface. This allows you to modify and view your current interfaces on the firewall. And if you put the command show, once you are inside interface, you'll be able to see all the interfaces that exist in your firewall. Starting from port 1, our internet port, and the older interfaces for sales and marketing teams. And if we go down, we can start seeing our VLAN interfaces in here. They don't have a port number, they have a name, and they always belong to a specific interface. So we can see that design department was created using IP address 192.168.0.1/24. It has Bing allowed, and it belongs to port 4. So this is a trunk under port 4. And for this trunk to work, you must give it a VLAN ID. VLAN ID for design department is 25. The same exists for our IT department. It has a VLAN tag 33. It belongs to port 4. And it has allow access Bing, and it has IP address 192.168.1.1/24. So now we need to create a new one. If you put the command edit, it doesn't just allow you to edit the existing items, but it also creates a new items if they don't find it. So if I start by typing edit HR, it says new entry added. So it detects that HR interface does not exist in my database, so I'm just going to create a new entry for it. And we just need to emulate something similar to this for HR department using the CLI. It's a lot more fun. So first, let's give it a VDOM, and this is something required to be added. And for VDOMs, they are basically a virtualization technology that allows you to run multiple instances of the firewall in the same machine. It's similar to VRF on a router, but since we are using the evaluation unit, this is not configurable here, or this is not supported in this version. So everything is just set VDOM root. So that's all you need to write in here. Without it, it will not be accepted. And then we can give it an IP address. So set IP, this is the syntax of the command, and we just put 192.168.200.1/24. So now we have the router IP for the HR department assigned to this virtual interface that we yet have to define the remaining commands. So we're gonna allow you to Bing these interfaces because this allows you to know that your router is alive and responding to you. And then we're gonna assign it an interface. All VLAN interfaces must be assigned to a physical interface. That's where they run. So set interface, if I just tab until I find the word interface, and I can just put port and start typing again, and port 4 is right there. And the last item we need is the VLAN tag. So I'm gonna do set VLAN ID 47. Now if I put end, I have my interface ready, and it did not reject any of my commands. So the last thing, we deployed a DHCP server for design department and IT department from the GUI directly from the create interface page. In the CLI world, it doesn't work like that. You need to go on the DHCP server as well and create one. Let's go and see how we can deploy it using the CLI. So the command for this will be config system DHCP server. Once you tab with this, it's going to be so fast to navigate around the CLI for the FortiGate. Once you put enter, you can put the command show. This will allow you to see which DHCP servers exist as of now. We can see we have multiple ones. We have one for our port 3, our marketing team. And this is the syntax that is used to create a DHCP server from the CLI. The entry number 2 or the second server is the one for port 2, the sales team DHCP server. And we see port or number 3, which is design. It has the DHCP servers for our design team. This is the one that we created from the GUI. And same for this one. And I just want to do the same thing. I see that now I have 4 servers. So the next number is going to be created in here can be 5. So I can put 5, or I can put 6, or I can put any number. It doesn't have to be the one next in line. And I can just use these same commands up until the gateway IP. 192.168.128.1 is my IT department. So I'm going to copy up until this part, but I'm going to use 200.1 to be my gateway. So this is the gateway for the HR department. It has the same mask. So I'm just going to copy this in as well. And I'm going to set interface. So it's going to listen for DHCP traffic on this port. And if I tab, it will show me IT port 1 and show me all the ports on row. I want to choose HR. And the last thing we're going to do is we're going to configure our IP range. So the GUI makes it more easier to create a DHCP server, but it's not that difficult to create it from here as well. Inside the DHCP IP range, we can create an entry for the range. This is different from the entry for the DHCP server itself. And all we need here is set start IP and set end IP. So start IP for this network will be 192.168.200.2. And for the end IP will be the last usable host IP in this subnet, which is 200.254. So now if I do end, I'm back to entry number 60. If I click show, now I have everything ready here for the HR DHCP server to work. I have my network router ID. I have my subnet mask. I have the interface, which is the VLAN interface that we created. And this is the IP range that the firewall will distribute IPs from to the clients. So if I click end, now everything is saved. Now I should be able to start deploying stuff on my switch 3 and test if I can segregate this traffic and then monitor how does it look using VLAN trunk. So now I deployed 3 different virtual PCs in here, one for each department. I have my port 0 connecting from switch 3 to the FortiGate trunk port, and inside the switch I created or configured 3 different access port 1 for my design department, port 2 for my IT department, port 3 for my HR department. So let's test this out. We're gonna run a link from each PC into the corresponding port on the switch. And we're gonna start all PCs at once. And if my setup is correctly, I should be getting unique IP addresses for design, IT, and HR from each subnet. Let's test it out. From my design PC, remember this is connected to port 1 on the switch. This port is tagged 25. So by the time it travels to the firewall, it will be tagged with 25, and this way the firewall will know it's coming to design department, and I'm gonna be using the design interface, which is a virtual interface, to route traffic back and forth. So from my design PC, if I put DHCP command in here, let's see which IP I'm gonna be given from the FortiGate. Now I got 192.168.0.2. This is the expected IP because it got from the design department. Let's see for IT department which IP we're gonna get. And for IT department I got 192.168.128.2. This is the first usable IP in this subnet. We're gonna do the same for HR department. And I got the same for my HR department. I got 192.168.200.2. So this way we've seen 3 different network traffic connecting and getting 3 different IP addresses using single interface on the FortiGate. Now, if we try to communicate between these devices, even though they are running under the same switch and under the same port, because they belong to different layer 3 segments and have different VLAN tags, they are not going to be able to talk to each other right away. So if we test from design BC to ping on 192.168.128.2, which is IT department IP address, we are going to be getting a timeout because the FortiGate will not allow this traffic to go through. Let's verify using our logs on the FortiGate. If we open the log and report in here and open forward traffic, since we allowed the traffic to be logged into the FortiGate, we can see here the design device coming from the interface design is getting a deny for policy violation. And if we look inside the packet, this traffic was coming on interface design and going into IT. It's not mentioning port 4 at all because all it sees right now is just VLAN tags. And this is showing you the VLAN interface working properly. We just need to add a firewall policy to our list to allow ping from these different interfaces. We have only been enabled between port 2 and port 3 back and forth. So let's create a new policy. And in the interfaces, we see different interface for each one. This will take much faster if we do it this way. So we can do config firewall policy. And if we just click show, now we see we only have these two interfaces or two policies, policy number 1 and policy number 2. In the same concept, we can build a new policy using edit 3 or edit any number except 1 and 2. And for source interface, instead of being limited to only a single interface from the GUI, we can set interface design, and once we click a space, we can type additional ones. We can put IT and we can put HR, and then we're going to do the same for destination interface, because we will be allowing all these three different subnets to ping each other so we can verify our connections. So we can do design, IT, HR one more time. Next item, we're going to be set source address. And for this, we can just leave it all for now. And destination address will also be all for now. And for the service or the port we're going to be talking on, we just need ping. So we can just open all and just tab until we find all ICMP. Finally, we want to allow this traffic to action accept. We want to allow this traffic. And for the schedule, we can put always. And then we can click next. If it didn't give me any error, that means it was able to successfully save it. If I go back into policy, I can see I have different interfaces in the same policy from the CLI. This also can be enabled in the GUI using systems, feature visibility, and then choose allow multiple interface policy from here. This way it will give you a check mark that allows you to build interfaces or policies with multiple interfaces. So if I go back here and start a new interface or a new policy, now I can select multiple ones in the same from the GUI. So now we have our ping policy that will allow traffic to work between these different departments for ping. Let me go back to my CLI screen. And from design BC, I want to open my same command again, and I want to do a ping 192.168.128.2, and now I'm finally getting response to the instance on the other side on a different VLAN. Now I want you to keep this running for a second, and I want you to do a sniff on that traffic in here. I'm trying to ping from this guy, design PC, and I'm pinging this guy, and even though they live in the same switch, the traffic has to be sent to the default gateway first because it lives on a different layer 3 segment. So traffic will flow from design, go to the switch, go to the firewall port 4. We will have a VLAN ID 25. Firewall will take it, it will look a policy and will find a policy that we just created for Bing, and then it will decide that this traffic is going to IT department based on the IP address, and it will send it to that sub interface for IT department, come back here and send it back to here, given that new VLAN tag is 33 that was done on the FortiGate side. So let's verify this. Come to the link in here and start capture. And if we look in here, the traffic looks similar to the first example we had. We see the traffic going from port 1 on the virtual PC, going into the switch. We don't see anything different here compared to the other example. But let's try to capture the same traffic on this link. The traffic has been ingested into the switch and will come out of this direction to get to the FortiGate, as that FortiGate has the default gateway. And once I open Wireshark, I want you to look closely at the packet details. Starting from the Bing request, we see here the normal layer 1 interface information, layer 2 information, and layer 3 information, but now we see a different entry in my Wireshark. This is called 802.1q virtual VLAN. And this is the small header we talked about earlier, which makes traffic get segregated and separate from each other on the same interface. We see here that the switch took the traffic from the host, which the host does not ever add any VLAN interfaces to any traffic. The host or the computer does not know anything about VLANs. So the traffic comes to the switch on this port, and if we open the switch configuration, we have this port configured to VLAN 25. So when it gets this traffic, it puts VLAN 25 stamp into it. This way, when it goes again to the firewall, it has this VLAN tag attached to it. Now if I look into the reply is the same traffic coming from the FortiGate. Look what happened. The ID for the VLAN changed to 33. So when the traffic is going, it has 25. When it's coming out of the firewall, it has 33. So the firewall does remove the old VLAN tag and it adds the new VLAN tag to the interface or to the packet. This way, when it comes back to the switch, it has VLAN 33 in the header, and we only allowed VLAN 33 to be on port Ethernet 2 connected to the IT PC. So this way, this number here is the only allowed VLAN to go into port 2. And this way, we are configuring multiple VLAN with different layer 3 segments on the same port. Thank you for watching.